Hello, everyone. Welcome to night 5 of Lambda School's mini bootcamp. We're just starting week 2 out of 2, so we're halfway there. My name is Deandra Ryan Moss. I'm your instructor, and I'm teaching you live tonight from Bisbee, Arizona. I do know it is a holiday today, so thank you to everyone who is here watching live, and anyone else who is catching up after the fact, no worries. So let me talk a little bit about Lambda School, and then we can get started with programming tonight. Lambda School is a 6-month computer science and web development immersive. So it's an entirely online, full-time class where we take you from the beginning stages of being a programmer to the point where you are hireable. So it's for people who are just getting into programming. It's for people coming from other languages that want to learn more about web development. It's people who have some self-taught skills but need a little bit of a boost to get to the next level. We take people fitting all of those categories and get them to the point where they are hireable. So as mentioned, it is full-time, though we do also offer a part-time course that lasts a year, and that runs in the evenings. So Lambda School is available to anyone who is interested and able to apply. A couple of the ways that we make sure that the doors to Lambda School stay open, first is the interview process. While we do have a coding challenge to initiate it, it is oriented towards people who are dedicated. It's the primary thing that we look for in the interview process is someone that we feel confident can learn. So we don't do a live technical interview. We don't put you on the spot. We just want to make sure that you are dedicating to doing what it takes to go through Lambda School. The second thing we do to keep the doors open is our tuition program. So instead of paying upfront, we offer de-risked, deferred tuition. So you don't have to pay anything to attend Lambda School. Instead, you can sign an income share agreement so that you're paying us back after the fact. So it's only after you get hired in that full-time programming job making $50K or over that you start paying back your tuition. And in that way, you're able to attend even if you're not able to pay a bunch of cash up front, or if you just don't want to. So that's Lambda School for you. I encourage all of you guys to reach out to Karen, Zachary, and Slack if you have any admissions questions. We always say if you feel like you're ready to take the admissions challenge now, go for it. You don't need to wait till the end of the boot camp, though a lot of people do, and that's totally fine as well. So in this mini boot camp, we just cover web development fundamentals, whereas the main curriculum dives really deep into back-end, front-end, different frameworks, as well as other CS topics. In this course, we talk about just the introduction to all the front-end languages. So last week, we saw HTML, CSS, and some intro JavaScript. This week, we'll be focusing almost entirely on JavaScript. So starting tonight, I'm going to do a little bit of a review of everything we saw last night. So we will see a little HTML, CSS just at the beginning tonight as a review. And then moving past that, we're going to go over functions. Functions are an idea I've very briefly mentioned within JavaScript, and they're extremely powerful. So we're going to take pretty much the entire night tonight to just break those down for you. And then we'll see some other interesting advanced JavaScript topics in the rest of the week. So let me go ahead and share my screen, and we can do that little HTML, CSS review, a little bit of a JavaScript review, and then we will talk about functions for the rest of the night. As always, join me in Slack if you're watching live, and I'll take questions at the end. So, all right, let's do it. Okay, up here I have CodePen open. As you guys know by now, CodePen is a sandbox environment designed for web development. So it lets us mess with HTML, CSS, and JavaScript all live, and it renders our web page over here. So right now we're just going to be using it to do a little HTML and CSS review. So, okay, let's talk about what I've put on the page here first. I've just done a little bit of a web page. We have these 2 divs. Inside the first one, I have a H1, a header, and this paragraph that contains a link over to Lambda School. And then down in the second one, I have a smaller header and then an unordered list. So not all the elements we've seen, but there are a few of them present. So let me remind you of what each of these elements does, the syntax of HTML and CSS, and attributes. So whenever we want to put a HTML element on screen, we have to have an opening header and a closing header. So let's look at this H1 for starters. I'm sorry, an opening tag and a closing tag. So in this header, our tag is H1. And so we have H1 in these little pointy brackets. And then over here, we have the closing tag. It looks almost the same, except there's a slash. And then within that, we have the actual content of the element. So as with this div up here, the content could be other elements, or it could be text, or it sometimes can be other things. So that's how you write basically any HTML element. You start with an opening tag, you fill it with content, and then you close it. And as we know, you're perfectly welcome to nest these tags within each other. In fact, HTML is designed to contain elements within elements within elements. Divs are one of our most basic building blocks. They are really the containers that tend to divide up our web page. So often if you see a div, it's because there are going to be other elements inside of it. And we see that in this code up here. Headers are also a pretty critical element. There are different weights of importance denoted by the numbers 1 through 6. On this page, I have an H1 up here and an H3 down here. Notice that by default, the different headers are a different size. We see that the H1 appears the biggest by default, H3 is a little bigger or a little smaller, and so forth. But as we also know, that size can be overridden pretty easily with CSS. We also have a paragraph. Within that paragraph is a anchor tag, a link, and then down here we have an unordered list. And the unordered list is a little different because we have to start with the actual list tag, UL for unordered list, and then for each item inside, we put in an LI, a list item. So in order to build a list, we actually have to use two different tag types, a UL and an LI like this, or an OL and an LI for an unordered list. So there's a little review of a couple of the elements that we learned. I also want to direct your attention to some of the attributes we have here. As we know, anchors, which are our link elements, have to contain an attribute called href. We use this to point to the actual website that we want to link. So I've done href equals Lambda school in quotes. I've also included the attribute target equals _ blank, which means that this opens in a new page. So there you have it. The last thing I want to direct your attention to is that I've put in a class and an ID. So notice that this top header here, this H1, over here is a class called important, and that the second list item spans also says important. We also have one ID called list header on our H3. So a little reminder is that both classes and IDs are ways of especially denoting certain elements, which helps us style. IDs are unique, so only a single element could be considered the list header, whereas classes can belong to multiple items. And we can see that here because two different elements have this class of important. So there you go. Let's go ahead and do some styling. So for starters, we can select a type of tag. So I'm going to select div. That means I have selected every div on screen. I'll start by putting a border around it. This is always nice with divs because by default they're invisible. When we put a border around it, we can see our two divs, but they kind of look a little cramped and weird. So I'm going to give it a margin of 2 pixels and some padding, or sorry, not 2, 20 pixels. As a reminder, margins are the space outside of the element, padding is the space within. So now we can see our divs really clearly. Let's go ahead and break down what I did here. I started with my selector, followed by the curly brackets, and then each of these is an attribute, a property that I've selected from CSS. So border is a CSS property, and the value that you put in for border is actually threefold. You start with the thickness, followed by the style, followed by the color. Margin expects, you can put there are a few options for margin. I usually just do pixels. Percentage is another way you can go. If you're curious on exactly what all these properties accept, Googling and looking at some documentation would be a good way to go. So I can, of course, select elements. I can also select classes. So if I want to select the class important, I do .important. So the dot says look for a class called important. And maybe for important, I want the color to be red. I want Let's also put a border around this one. We'll do, also make it red. Okay, so our important items are very clearly important now. So we can see that it's useful to group things together by classes because often we have different items that we want with a specific style. The value of classes are, of course, that we can apply the same style between different types of elements. I've applied the same style to a header as a list item, but also they can be nice if we don't want to apply things to everything. So perhaps we want a style that only goes on certain divs. In that case, we would create a class. We can finally select by ID. ID is selected with a hashtag. So I'm going to select my list header, and we'll go ahead and give this a background color of blue, and we'll make it white. So there we go. And let's go ahead and give that some padding as well. How about 10 pixels? There we go. So I've done 3 different types of selectors. I've selected every div over here by element type. I've selected all of the elements with this class, and then a single element with this ID on it. As we explored last week, what seems like a fairly simple idea gets extremely complicated once we put it into practice because there's all sorts of competition going on. We know that IDs take priority over classes, take priority over elements, but it can get confusing when things have multiple classes and you're selecting combinations of classes and tag names. So as you hopefully learned from the homework, even though this is a simple idea, it definitely takes a lot of practice of mastery to learn exactly how to use CSS to really style your page in the way you want. The biggest takeaway here is select and then put in all of your properties and values to style your page as needed. So that is just a little HTML CSS review. We do have a question about needing the head. So there are a few, because CodePen is a sandbox environment, there are a few things on a regular HTML page that we can skip. So I haven't put on a couple critical tags here. So every HTML page has an HTML tag, a body tag, a head tag. As it were, I've skipped all of those, and I'm allowed to do that because I am working in CodePen. So it's a little bit of a shortcut. It's nice for learning, but it also can make us lazy. So if you're working on building HTML pages outside of CodePen, I would definitely look that up. Because we pretty much stick in CodePen for this lecture, I'm not going to dive into more detail on that. All right, so that's it for the CSS HTML review. If you want to learn more about those in detail, I would go back and rewatch some of those first 2 videos from last week. But let's go ahead and switch over to JavaScript so that we have plenty of time to review that and then explore functions. So just a couple things I want to introduce from reintroduce from last week. So first of all, I'm over here in Replit, another sandbox environment. So I have this JavaScript Replit pulled out. That means I can write JavaScript in here. I can press run, and all my code will execute. Everything that's logged to the console will appear over here in white, and my final line will be logged in green. So let's go ahead and throw some code down on here so we can review how that works. All right, so I have declared 3 different variables here. So I start by declaring X and Y. We see that I declare them with the keyword const, followed by the name of the variable, and then I indicate with the equal sign that I'm going to store a value in it, and finally I actually type out the value I want stored in here. So this over here is the actual JavaScript object that I'm creating, in this case the number 4, and then I create a place to store it called X and store it in there. The same thing happens on line 2 with Y. We see that on line 3 essentially the same thing is happening, but there's a subtle difference. Instead of actually explicitly typing out a number or a string or some other value, I've put in a JavaScript statement. So I've actually pulled on these 2 values of 4 and 7 through their variable name, But because this will resolve to the number 11, I'm essentially doing the same thing. I'm just typing some code that resolves to 11 and then storing it in a new variable called z. And finally, if I check what's in z, which I can easily see by running replit, I see that 11 is stored inside of z. So we have some variable declaration here. We also have some actually accessing values to create new values. We see that we can do mathematical operations on numbers. And in this example, we've only used one data type of numbers. As we know, there are numbers, there are strings, which are text, there are booleans, which are true or false. We also have undefined and null, our friends that denote data is missing or there is no data. Those are our primitive types. Then we've also experienced functions, things like console.log, which is a built-in, this is a type of function called a method. It's something that's built in that we can execute with parentheses to cause some sort of effect. So these are pretty much the types that we've seen so far, but we've kind of just brushed over this last type of function. So that's what we're going to be exploring in more detail tonight. A couple more useful tools that we've explored throughout are based in control flow. So control flow is where we determine how will the code act based on some conditions. So first of all, we have if-else statements. So when we have an if-else statement, we're saying there are two options of which set of code might run. We might have a bit of code in the if statement that runs or the else statement, and they will execute depending on this condition in the parentheses. So if I console log true on the if and console log false, we'll see that in some cases true runs, in other cases the else statement runs and we get our log of false. So up here, as we saw, there can be a Boolean, there can be something like a comparison that resolves to a Boolean. There can be a combination of Booleans using our or our and operator. There also can even be something like a number up here, and that will resolve based on its truthiness value. So those are if and else statements for you. Just a very brief review of those guys. And then at last we saw loops, and loops are super great. They allow us to have the same line of code run multiple times with different conditions. So let's say that I wanted to log the numbers from 0 to 9. I could create a loop like this one here, if I can put my semicolon in the right spot. Okay, so we use the keyword for. We use let, which is another way of declaring variables. Let is declared when let is used to declare variables that will have mutable values, so values that are changing. It's pretty critical we use let when we're writing a loop because our index, our counter, is going to be incrementing in some way or possibly decrementing as we go through our loop. So this is just a temporary variable we create to figure out where are we in the loop. We're going to start it at 0 in this case. We're going to continue to loop until this is no longer true. So once I reaches 10, we'll quit our loop. And then each time at the very end, we are going to increment I. So that's what happens. This line number 2 will execute 10 different times as the value of I changes. So loops are really critical. They're a really key piece of creating dry code. Dry code, as a reminder, is code that follows the principle of don't repeat yourself. So we would not want to see 10 console logs in a row. Whenever we're going to be doing something multiple times, even if some pieces of it are slightly changing, we don't want repetition. And as it were, for loops are a good way to do that, but functions are probably the best way. So let's go ahead and start to introduce some new topics. We're going to talk in detail about something called functions. And just like everything else we've seen, functions are a type of object in JavaScript. They just might be a little bit more complex than something like a string or a number. So the example of functions that we've seen so far that we've worked with are our methods. But methods are just one example of a function. So I'm going to go ahead and write just a very simple function here. And then we're going to break down what's going on. So, okay. So without breaking down in detail the syntax of this function, I will say that I've created a function called add2, and it takes in a number and spits out a number plus 2. So functions in the programming sense are pretty similar to functions in the math sense, especially this one because we're actually doing math. But in the more general sense, we think about functions as being something that where we have some sort of input, some sort of output, and then some sort of logic happens in the middle. Of course, sometimes we might not have input and sometimes we might not have output, so it gets a little more complicated. But thinking about input and output is a good way to go. So let's play with our add2. So let me first start by actually looking at this add2 variable name. So add2 is a function, and this is a subtle point. So this variable here is a function, which doesn't mean that so it's basically the potential for logic to be executed. So think of this variable as being the possibility of x having 2 added to it, or think of it as a machine that's capable of adding 2 to a number. But we're not actually adding anything yet. We have to turn on the machine before any addition will happen. So in this state, when we just grab the variable name of a function, it's like a machine that we haven't turned on yet. The same thing can be said about the methods that we've seen so far. So if I just type out console log or math.random, these are all functions. They're all right now like machines that haven't been turned on. Of course, they're not very interesting to work with unless we turn them on. And that's what we do with the parentheses. So if we're using this machine metaphor, we can think of these parentheses as being a button. If there's no parentheses, we haven't pressed the on button. And this is where the metaphor breaks down, which is that if there's any sort of input into our machine, it goes inside of the parentheses. So add2 takes in one number, 4. And let's actually bring back console log. So as I mentioned last week, console log is kind of a weird one because it can take in one or more inputs. So this would be a valid execution of console log. I could also put in several more inputs, and this is also valid. So that is one thing that makes JavaScript pretty unique, is that sometimes you'll have these functions that will run slightly different depending on how many bits of input you put in. So we've executed add2, we've executed console log, and then down here, let's execute math.random. So I wanted to bring this one up as well because this actually has no input. So let's break these each down and talk about this idea of input. First of all, we would call the value that we put inside of a function as our argument. So 4 is the argument that we're putting inside of add2. In this case, we're putting in 3 arguments, the string hey, hello, and oi. Down here, math.random has no arguments being passed in. So really, the number of arguments and the type of data we would put in is going to depend on the function. Add2 just adds 2 to a single number, so of course, it's going to expect a single number to be put in. Console log logs things out to the console, so it's a little more flexible because it can log 1 bit of input out, it can log out multiple. And math.random creates a random number every time. So there's really no need for user input. So we can see 3 different functions functioning in 3 different ways. So another subtle point is that now that we've turned on the machine, this line of code is no longer a function. It's called a function call. So by itself, without the parentheses, we have a function. And that's a JavaScript data type. So this whole line would be called a function call. So a function call isn't a different type of data. It's more just something we can do with the code. Kind of like we can declare a variable or we can execute a loop. We can also call a function. So these lines of code would all be considered function calls. You can tell because of the parentheses. And in terms of this question of what do each of these lines of code resolve to, well, that begs the question of what's the return value? What is the output? Add2 has the return value of a number, a different number than the input, but a number. So this line of code would resolve to a number. Down here, console log's kind of a weird one because even though it will log these strings to the console, it won't resolve to anything. So this line of code will actually resolve to undefined. Some functions don't have a return value, and those always resolve to undefined. Finally, we have math.random, which will also resolve to a number. So it's important to ask, what is the input? What arguments do we have to put in? And what is the return value? What will the code resolve to? So let's go ahead and look at our add to in action to make sure it works. We can always tell the return value of something by running it through replit. If our function call is the last line in replit, then any return value over here will appear in green. So if we bring back our console log, we can see that yes, our words were logged to the console, but in green we see undefined. And we know that the green over here refers to the last line of code, so we can be assured that console log has no return value. So that is our basic way of thinking about functions. As we've seen, there are methods that are types of functions, and we know that something is a method because it's built on to another object. So when we see something dot something with parentheses, that's going to be a method. Those are built into JavaScript. So those are built-in functions that exist on some sort of object. But we can also just have functions that stand alone, like add to. So that's really what we're going to be exploring today, is these standalone functions. And what's great about these things is we can write them ourselves. So now that we've kind of walked through what are functions, how do we use them, what's the difference between a function and a function call, let's look at how to actually write the function. So let's look over here. Oh, and I want to do, there's a little question about multiple arguments that I'm just gonna go ahead and address right now. So you can have as many arguments as you want. Over here, when we specify the function, we specify how many arguments it has. So if we ever put in extra arguments into a function, it will just ignore all the extra ones unless behind the scenes we've specified that we expect more. So you'll see more of how that plays out in just a minute as I talk about how to write the functions. Okay, so let's talk about how I created add to. There are a couple different ways to create functions from a syntax perspective. So I'll start with this one. So I start with the function keyword. We always need the function keyword when we're creating a function. I follow that by the name of it. Just like any other variable name, this is a name that I come up with to try and specify what this thing does. This can be anything we want, but we do want to name our functions something meaningful so that our users or our fellow developers don't get confused. So then we have in parentheses any parameters. So now is a time to briefly mention the difference between arguments and parameters, which I will go over in a little more detail in a minute. So when we're talking about, in the general sense, what goes in, we're talking about a parameter. So a parameter is, what does the function expect? For example, it might expect a single number. So we see here that add to expects a single number. We can tell that it expects one parameter because there's one name over here. So if it expected 3 numbers, we would maybe do X, Y, and Z, but we can see it just expects 1. The reason we know it expects a number is we can kind of just gather that based on the name of the function and that I've named it X and that we're doing addition. But to know what kind of values a function expects, you would want to look at either the comments by your fellow developers or the documentation if you're looking at something built in and formally documented. So a parameter is more abstract. It's this general question of what type of data and how much data does the function expect. An argument is what has been passed in a specific function call. So an example would be 4. So add to doesn't take in 4 per se. in this specific case, it takes in 4, so we'd call for an argument because it's specific to this function call. But in the general sense, you would just say it takes in a single number. So parameter is general. So if you can describe the input of a function and have that description apply to any call of the function, then that would be a parameter. Whereas if you're talking about a specific value that was passed in a specific case of it being called, that's the argument. Honestly, it's not the end of the world if you mix these things up. I constantly find myself accidentally swapping the two, and I apologize in advance for that, but it is an often asked question of the difference between argument and parameter. And you'll definitely be able to demonstrate your subtlety as a programmer if you can articulate the difference between these two things. The biggest takeaway being functions have inputs. So back to the syntax over here. We see our parameter or parameters in some cases in the parentheses here. These can be named. I could call them anything useless I wanted. Of course, we always want to also name our parameters something meaningful. So because I'm doing math with numbers, X would be a good parameter name. So following the specification of what kind of parameters we have, which happens in the parentheses, after that we have our friends, the curly brackets. So inside the curly brackets, we have all the logic of the function, including the return statement. So maybe this is a more complex mathematical operation, and we start by taking x to the power of 2, and then we divide that power by 7, and then maybe we return that. So as we can see here, this is no longer accurately named add 2. It's now a much more complex mathematical formula. But we can see that anything that happens normally in JavaScript can happen inside of a function call. We can declare variables, we can do math logic, we could have even if statements and loops inside of here, which we'll play with later. So anything can happen inside of this function call. But at the end, we want to return our result. So whatever result we have ultimately needs to be returned with a keyword called return. So the return will do the keyword return followed by the value that we actually want to spit out. So if we put this back to x plus 2, we can see that we're adding 2 onto x and then returning that value. And that's how we created our add2 function. So we started with the function keyword, we named it, we specified our parameters, and then we did all the logic, including the return statement, which because this is a really simple function, we were able to do that logic in just one line. So there you have it, add2. Let's go ahead and look at another function example, and I'll show you a new way to write them. So we could do add excitement. If I can spell excitement, yeah, that's right. I think, hopefully, sorry about my spelling if that's wrong. So we'll just do add exclamation, actually. So this is going to take in a string. So I'll just say string for str for string. So once again, I'm just, oh, and I need my function keyword or it won't work. So once again, I've just named this parameter in a really general way to let the user know, hey, this is expecting a string. Once again, this is something I came up with. I could have typed out not string itself, but I could have typed out phrase or text or anything meaningful like that. So this looks slightly different. We're still using our function keyword. We're still specifying our arguments. We still have our curly brackets, but now we're actually taking what's called an anonymous function, which is a function missing a name, and then we save it with a single equal sign into a variable name that we declare as usual. So there are two different ways of declaring functions. This one looks a little bit more familiar probably because it kind of parallels this way of declaring variables we're used to seeing. In this case, instead of storing in a string or a number, we're just storing in an anonymous function. Over here, we don't declare a variable, but we use the function keyword and a function name to create a function. So let's talk about the difference between the two. Actually, let me write this function, then we'll talk about the difference. So everything that happens in the curly brackets is exactly the same. We just want to create our logic. So in this case, I'm going to take my string and add on an exclamation point. And then, of course, I need to return it, or it won't be outputted out of the function. So now if I call add exclamation, put in hey there, we get hey there with an exclamation point. Little argument parameter reminder, our parameter of this is a single string, whereas our argument in this specific case is the string hey there. So let's look at these two different styles. So what happens if I try to call my function at the top of the page? So I get an error that add exclamation is not a function. So this is really similar to what happens when I declare, if I declare a number over here and set it equal to 8, let's say, and then if I try to, let's say, console log x up here, nothing is logged because as far as the code is concerned, x doesn't exist yet. It's been declared, but it hasn't been defined. Same thing with add exclamation. This variable exists up here on line 4, but it hasn't been turned into a function yet. This is this idea of hoisting. So this bit of code is hoisted up and happens before anything else, but nothing has been stored in it yet. So, however, let's try doing add to. So if I'm going to console log our result. Actually, let's do this. Into something called z, I'll do add to of 3. And so notice that return values can be stored into new variables. So if you have a declaration like this, where on this side is a function call, whatever is outputted here, whatever the return value of this function will be stored into z. And then let's console log z so that we can see if z exists and if it's what we want it to be. So notice that now it works. Add to is defined, and the code knows that it is a function. So this type of function declaration is going to be hoisted. That means that it is available anywhere on the page, even above where we write it. As far as the functional differences of these two, at this point, I would say practice doing both. They're both useful. This one might be nice because it's a little more familiar. It also gives you a little bit of a practice with this thing called anonymous functions that will come up later. This one is nice because the function can be used anywhere on the page. So I would say just practice both styles and be aware of this hoisting difference between the two of them. So those are our two different ways of declaring functions. So let's go ahead and just do a couple more examples for you just to make sure that you're getting comfortable with how to write them, the syntax, this idea of arguments, parameters, return values. So, okay, so let's try one called, let's do an add function. We've seen a lot of examples of functions that have a single parameter. Here is one that has 2. So in this time we do x and y. And of course, we just want to return x plus y. So once again, a pretty simple one-line function. Now, however, it's expecting 2 arguments. So in here, I have these 2 arguments of 3 and 4. They're specific, so we call them arguments. Up here are the general parameters of x and y, just saying put in 2 numbers. So if I go ahead and call my add function, I see the result over here. And as I mentioned before, if I put in extra values, add will just ignore them. It's only looking for these 2 values because we've said, hey, we're expecting 2. So what happens if we leave off a parameter, if we try to only put one thing in? Well, notice over here that we got not a number. That's because we were trying to add a 3 with undefined. So make sure that you're not leaving off critical parameters because your function won't work as intended. So the next one I want to do is the CNAME function. Oops. So we're going to create a greeting string. So I've just started with hi, I am, and then I go ahead and add on the name. And as a reminder, when you use the add with a string, you just kind of concat these two things together. So I've created a greeting, and then let's go ahead and console log that greeting. So if I do say name and put in my name, over here, the greeting is constructed and then appears on the console in white. So the say name does not have a return value. And when we can actually look inside of the function, it becomes pretty clear when we have a return value and when we don't, because we always have the keyword return if we have a return value. Notice that there's no keyword return anywhere in here. So this thing is not going to have a return value. The other way we can be sure that there's no return value is that when we actually execute it on line 13, we can see that that line resolves to undefined, which is a good way to tell that a function call has no return. So even functions without return values can still be useful if they're creating some sort of other effect, like logging to the console. So there's a couple more examples of functions. Let's go ahead and talk about scope. So I very briefly introduced scope the last couple nights of last week. We saw that there's a global scope. That means that, essentially that just means that when I create a variable, it's available globally. So if I just create a variable willy-nilly, X is going to be available anywhere. It's on what's called the global scope. But if I have something interesting going on, like an if block or a for loop, I'm kind of not writing these out entirely. So inside the if block, inside these curly brackets, and inside the for block, there's something called scope. And there are sort of different rules that apply. As it were, functions most definitely have function scope. So if I create a function called scope example, it'll take in a Boolean and a string, let's say. And then let's go ahead and do negate is going to be the opposite of the Boolean. The string is going to be, let's go if bool console.log string, and then we'll return it. Okay, this is totally convoluted. Let's talk about what's going on here first of all before we get into scope. So we're taking in a Boolean and a string. First, we negate our Boolean. Then we actually, if negate, then if our negated Boolean is true, we'll console log our string, and then we return our negated Boolean. So little convoluted. We put in true and hello, it will not log and will return false. But if we put in false, it will log and it'll return true. So there's a little fun example of some of the weird things we can do with functions. But let's talk about scope now. Scope is important. Okay, so okay. Inside of these curly brackets exists something called function scope. So the function scope starts at the top and it ends when we reach the bottom. So for starters, we know that anything in the global scope is available in the function scope. So if I wanted to also console log X, which remember exists in the global scope, I could do that. So yeah. So let me make this a little more simple for you guys. Okay. I'm going to call this global scope, and then down here, I'll call this function scope, and we'll return that variable. Okay, so I've just highly simplified this. I was having a little bit too much fun with conditionals there. So, okay, scope example takes in a Boolean, it just negates it and returns it. So let's see if we just do scope example of true. It returns false if we do scope example of false. It returns true if we do scope example of something truthy, like a string. It will return false, etc. Okay, so now let's talk about scope. So this global scope variable is available everywhere. So if I want to throw in console log my global scope variable, I can do that. I can, once I actually run scope example, notice that 9 is logged to the console. That means that this variable, I was able to use this variable that exists out here globally inside of my function scope. So this thing is available everywhere. But as it were, the opposite is not true. So if outside of the function, I wanted to say, try and console log function scope, so that's this variable that I declare right here, it won't work. I get reference error. So it might seem strange at first because I'm getting this error that function scope is not defined, but over on line 8, which is above line 11, I'm defining it. But that's because of scope. It's like we create our own little special temporary universe every time we run a function. So anything we create inside of here will exist only until the end of the scope, the end of the curly brackets. So things inside of functions we cannot reach inside of it from the global scope and see what's in it. The same is true about our arguments. So if we try to access our parameter name, bool, we still get that same error because these parameter names will only be defined, we'll only be able to play with them as long as we're inside of the function scope. So that can actually be really nice because we can create a whole little world, a bunch of variables inside of here, and then once we're done, we're done. They're no longer accessible. So this is actually an incredibly useful thing because it prevents us from having a bunch of repeat variable names. It allows us to control exactly what whoever's using our function sees and doesn't see. And it also illustrates the importance of our return value. So of course, we can't just access function scope that we created in here, so we need some way of passing things back out of the function. And that's why we have return values, because of all the logic that exists inside of the function scope, we can only send one piece back out to the user, and that would be our return value. So there's a little example of scope. Once again, scope is just this idea that whenever we're inside of, excuse me, whenever we're inside of kind of a special little world in JavaScript, like an if block or a for loop or a function, that different rules apply. Sometimes different keywords are available, like return only makes sense as a keyword inside of a function. Kind of like inside of a loop, continue or continue or break will only make sense inside of there. So there are always sometimes these keywords that only work inside of a scope, but more than that, we have to watch out for our variables that we declare inside of a scope because they're probably not going to exist once we get back out. So that's a little review of scope for you guys. The next thing I want to talk about is return values. So we have definitely discussed return values already, but I want to take a little bit of time to explore them in a little more detail because as I just illustrated, they're pretty critical. They're our way of giving some output of, expressing the logic that we've actually executed back out to the user. So, and I will answer, I just saw a great question in Slack about multiple return values, and that is absolutely something that I will discuss here. So, all right, let's look at a few more examples. So let's start with our basic add2, our very first function friend. So this one is kind of our golden case of a return value. It's pretty straightforward here. We just we just do some logic. We take in a parameter, we do some logic, we return it out. As we saw, we can tell our return value in two different ways. The first is that we look at our actual function logic and we see the keyword return. The second is that when we call our function, we can see over here that it resolves to a value. That means that we can store that value if we want. We can use it in other places. Really useful. So nice little return value here. We've also seen some examples where there are no return values. So a great example is if you have something that logs to the console. So if we just have log, we'll call this log plus 2. So instead of returning it, we just want to log a number plus 2 to the console. In this case, no return value. And once again, there are two ways to tell that this function does not have a return value. The first is that we see no return statement in here. The other is that when we run it, we see that this line of code resolves to undefined. So even though, yes, our 7 has appeared in the console, in green, we can see that this has no return value. So often we want a return value, but not in every case. Sometimes we might have a function that has another purpose, like, for example, console logging. So let's look at an example with multiple return values. So, okay, let's try this. We're going to create a function called absolute value. And as we know, an absolute value function already exists built into JavaScript, but we'll just do this one. So this takes in a number, and as we know, the absolute value of a number is we make the number positive. So if it's already positive, it stays the same. Otherwise, we negate it to make it positive. So we want to first check that first condition with an if statement. So if x is greater than or equal to 0, then we know it's already positive, right? So we just return x. Else, then we know it's negative, so we can do a double negative to make it positive. So let's make sure our absolute value function works. Put in -9, looking good. Put in 11, looks good. Let's try a negative decimal. Looking good. So does this function have multiple return values? It depends on what you mean. So literally, I have used the keyword return twice. So you might think, yeah, multiple return values, but it's not really what's going on. It's more like multiple return options. So in some cases, this return value will execute. In some cases, this will, because of our if else, but never both. So that is, but yeah, so that is kind of to answer this question of multiple return values. Yes and no. We can use multiple return statements to, work with things like conditionals, but ultimately this thing is only going to return one number, and it's not possible for a function to have more than one return value. As we'll see, I think tomorrow, there are certain JavaScript objects that we could use to return perhaps multiple pieces of data all lumped together. But for now, let's just say that there can only be one return value, even though we might have multiple return statements to keep our function dynamic. So what happens if we just write, let's call this return example. I'm just going to do 2 return statements. So now we don't have any ifs or else's going on, right? I've just written 2 returns in a row. So what is this function going to do, this return example? Well, it returns the first. And that's because even though we think of the function scope as going until the end of the curly bracket, if it ever sees the keyword return, it quits. So once it sees the keyword return, nothing else is going to run. So let's look at another more brutal example of that. So let's say we have a return statement at the top of our function, and then I'm going to do a bunch of things. And I'll console log x or z plus y, and console log at the bottom of the function. Okay. So we have a return statement at the top of our function, and then a bunch of other logic down here, including 2 console logs. So if I run this, notice that these other console logs never execute. We get our return early log and that's it. That's because once we see the keyword return, we quit. And we can take this a step further. We don't even need a value. If we want to tell the function, hey, it's time to quit, then we can just do return. So notice that, sure, there's no return value here, or it executes as, or it resolves as undefined because I haven't said to return everything, but I have prevented all of these lines from going. So this seems like a weird example, but there's some cases where this might be true. So let's say that we have some function called check age, and it takes in an age variable. So first of all, we want to make sure our age is valid. So we say if age is greater than or equal to 0. If someone has put in a negative number, something weird is going on. So actually, sorry, let me do if age is less than 0. Then let's return, because at that point, okay, clearly our user has put in some incorrect input, something weird is going on, let's just return out. And then down here, we might have more logic. Even including perhaps another return statement. So if I run check age, let's make that more interesting. So if I do 29, we get our console log down here. So we get down here past the if statement. But if I ever put in, -2, we would never get our log because we've used this if statement to kind of check if age is valid, and then a return statement by itself to just say, okay, just quit out. So you will see returns used in this way. They're most often used to actually give the user back out a piece of data, but sometimes they're used just to say, okay, quit the function. We don't want this thing to run any further. So that is functions for you. A really important piece of the JavaScript puzzle. They really open up a world of different things we can do. They really are critical in this idea of not repeating yourself, because you will in your apps and in your projects find yourself running the same bits of logic over and over and over again. And so functions are a way of just creating one set of the same logic that can run differently based on arguments. Yeah, so that really just opens up a world, and you'll have a ton of opportunity to practice that on the homework tonight. So I'm going to go ahead and just mention one thing from the homework tonight, and then I will open up the floor to questions for the 2 people who are watching this video live. So, okay, so the homework for tonight is pretty straightforward. It's just a bunch of functions that you have to write. But there's one example on there that I wanted to just talk about because it's kind of conceptually interesting. So let me copy it over real quick. Okay, cool. So this is one of your homework assignments. It's a function called getHTMLTag, and it takes in a tag name. And so you would, I don't want to give away how to do it, but the goal would be to return out a string that looks like an opening and closing tag. So the reason I want to talk about this one in particular is because something kind of weird is going on. There might be this question of, is this HTML or is this JavaScript? So to clarify, this is JavaScript. We can see a JavaScript keyword. We can see the function syntax. We're going to be using a return statement. This thing is a string. So we're creating a string that looks like HTML code. So we're actually we are writing HTML code using JavaScript. So this is really cool and really subtle and kind of mind-boggling, and is kind of starting to think like this is pretty key for actually integrating these JavaScript skills into web development. But I also don't want you to overcomplicate this. You're just trying to create a string that looks like HTML code. So we could maybe copy and paste our string that we're creating over into CodePen, and it would work as HTML. But for right now, we're just kind of mocking out HTML using JavaScript. And that really abstract stuff where we use one language to interact with another language, that's starting to get into some really subtle but important stuff. So we have a couple problems on the homework tonight and throughout this whole week that'll help you guys practice thinking like that. So that I just wanted to mention briefly. You'll have a bunch of other functions to practice on. And that is all I have for you guys tonight. So thanks for the questions you've been asking throughout the lesson. Does anyone have any follow-up questions on functions before I let you guys go? All right, Slack is seeming pretty quiet. So I think that it's a holiday and I guess we'll just call it early. So not really early, I guess it's 6. Oh, I see a couple people typing. Let's make sure there's nothing that anyone needs to know. Cool, it looks like everyone's feeling good. So that will be it for all. Okay. All right, thanks so much for coming to week 2 of Lambda School. Tonight we went over functions, which I think are really fun. They really open up the world of what's possible. I think if you guys are playing with some of your projects on the side, you'll start to see that all of a sudden a lot more just became possible with the introduction of functions. So enjoy practicing those. As I mentioned at the beginning, we're not doing the formalized homework thing tonight, so just you can get in MBC after hours if you want. That's a good place if you want to ask questions and kind of interact with people, because everyone's just kind of doing this on their own time for tonight. Starting tomorrow, we'll resume homework as usual. And yes, you can still turn in homework late. I encourage you to not feel like you have to have everything finished in one night. It's a lot. It sometimes is better to just give it a few days to digest. So give it your all. Try and work on it tonight if you can, but definitely don't be stressed out if you're not totally finishing it tonight. So I think a lot of people find that they have to go over and redo things and let things gestate before these concepts start to really click. So, all right, that's it for tonight. I will see you guys tomorrow.